Good morning, everybody, and welcome to today's DrayTek webinar. Today's webinar is called All You Need to Know About Cable Modem and ONT Technology, or I guess to kind of summarize, it's kind of all things fibre, but specifically all things fibre to the premises. My name is Julian Hubble. I head up DrayTek Sales. I'm the Sales Director, and after my brief introduction, I'll be introducing Alex, who's going to run the majority of this presentation today. So for those of you that don't know Alex is our CTO, been with the company many years, and I'm sure we'll share some useful information and insights into this exciting kind of new technology. So most of us will understand that in the UK we have a big broadband infrastructure that's based around mainly BT twisted pair lines that provide this DSL technology, kind of known as, I suppose, fibre to the cabinet, where you've got fibre to the cabinet and then a line connecting to the premise. What we've obviously seen is a huge growth in fibre, and many people and premises, many people and businesses now can get fibre to their premise. So this is all about the different technology surrounding that. And you as our dealers, I'm sure, will be selling more and more of this type of technology. So we certainly hope you find this useful. I'll also say that many of you will be aware that there's been a worldwide shortage of components. It's affected all parts of our industry. And unfortunately, we have been affected on our DSL router and modem range. There is still some product available. We're working very hard to bring it in. But what I can say when it comes to our cable products, or fibre products, if you like, we have incredibly good stock of this. So if you are putting in this type of technology, you can be sure that DrayTek will have the products that hopefully can support you in these types of solutions.
Thank you, Julian. Hello, everyone. So just start by briefly going over some of the agenda that I will be covering today. We'll start off by looking at the technologies involved. So we've got GPON and also DOCSIS as the two focuses for today, and we'll look at some of the street furniture, so what there is kind of deployed on the streets, and give you an idea about how you can kind of identify some of the different parts of the network. And then we'll look at the network topology and look at the modems themselves, the cable modem and the ONT. Then we'll have a look at how we connect DrayTek equipment to them. It's quite straightforward, but it's always helpful to cover that. And then we'll look at some tips to do with troubleshooting and disconnection problems that you might see with these technologies, which is slightly different to the sort of troubleshooting you may have done with something that's based around twisted pair copper with the FTTC type or ADSL connections. Then we'll have a Q&A at the end where you have an option to ask any questions. We can do this over the audio, but also any questions you ask during the chat, we can reply directly to you, as Julian mentioned, but also we can take some of the most popular questions and cover those over the audio at the end. So we will move on to looking at the technology. So as Julian's mentioned, there's some ambitious plans with rolling out fibre, and hopefully this will improve the quality of the connections for everyone in time. But let's just take a look at the general scene. I know we've covered some stuff relating to this in some previous webinars, so I just wanted to put up a comparison of all the different technologies, although we're only really focusing on the FTTP and Virgin Media connection today. So we can see that traditionally it started off with just a copper from the exchange to the premise with different copper runs, and then fibre started to get introduced to the network. And then the most common one, VDSL, is fibre to the cabinet, which is mainly fibre but does have a short copper run of a few hundred meters and gives connection speeds up to 80 megabits per second. Then the two that we're focusing on are FTTP and Virgin Media. These are fibre to almost all of the connection. On FTTP it's fibre all the way, and then on Virgin Media it's fibre pretty much most of the way, but we'll look at the where coax fits in on Virgin Media, and the connection speeds you can get are well in excess of the sort of ones you'd be able to get on the traditional copper networks. And I've got here the connection speed 330 to 1 gig for FTTP. There is lower speeds that are offered as well, so people aren't forced to upgrade necessarily. There are lower speeds for people who don't really need it, based on the packages, but the main focus is looking at kind of 330, because that's the step up that you can't really get on VDSL or even on GFast. And then we've got the Virgin Media one as well. So if we look at the kind of fibre rollout plan to get an idea of the current coverage, currently there's about 4.5 million with Openreach that are FTTP, and they're planning to up that to 20 million, or sometimes I think that may change in ambition, but it's roughly going to be around 20 million by 2025, hopefully. And then with Virgin Media, currently it's 14.7. This is already a really large number, because the whole of their existing network can potentially be considered as kind of fibre, and they're planning to increase that to 17 million. Then there's some other players in the market as well who are rolling out networks. So those are all based around GPON, so very similar to Openreach. So I'm not covering those in detail, but the principles of everything with how they're deploying it are very similar to the Openreach GPON-based deployments. So as we can see, there's quite ambitious plans, and we're looking at an increase, and I think it's clear where the direction of travel is, which is going to be good. So let's now look at the kind of street furniture and what we would see kind of on the network around the country. Be looking at kind of FTTC, FTTP, and cable. Firstly, the FTTC. Not going to dwell on this much, but it's just worth putting it into context. So the FTTC stuff is all the kind of generally the green cabinets you see. So you've got the traditional FTTC cabinets that's often got some sort of branding, like fibre broadband is here type things by Openreach. That's where the VDSL DSLAM MSAM is placed, and then we've got the primary connection point in the middle there. That's where all the copper cables go to the premises, and then those then link into the cabinet as well. And the far right hand side, there's a junction box that's at the premise, so that doesn't have any fibre in it at all. That's just a twisted pair copper if it's an FTTC deployment. Then if we look at FTTP, it's a little bit more boring, because there's not as much stuff to see in many cases, because a lot of it's hidden in the joint boxes and in the chambers underneath the street, and just has covers on them. The covers may be labelled Cat V, or alternatively might have some sort of BT logo, or in some cases, depending on how long it's been, there's various different operators that have placed them in time, so there can be kind of like Telewest logos on some of these as well. But if we look inside them, you can see there's things called a kind of a splitter and a node and a manifold that can be inside underneath these chambers, and that's where the GPON is kind of sent to, and then it's spliced off and then directed to different properties. And then also you can have them on poles, so there's a connection box terminal there that can be put on a pole if there isn't the kind of understreet. So if there's overhead stuff, it can still use FTTP with deploying the splitters or the manifolds on a pole. And then if we look at the cable side, so any of the Virgin Media stuff will be in a grey. It's actually called goose grey is the kind of name of the colour, and the Virgin Media cabinets have the DOCSIS equipment in them. They may though actually have fibre optic equipment in, depending on the deployment. So we'll talk about that in a little bit more detail. But you kind of have the larger ones tend to be the one on the left may then act as relays to some of the smaller cabinets, which have kind of potentially amplifiers or split off the signal. And then going further, if we look at the premise, there'll be some sort of duct going underneath the front of the house, and then you kind of see these either grey or green ducts. The green ones are Virgin Media and the grey ones are Openreach, and you may sometimes see a blue rope. That's to help with the rod and rope process, where they pull the fibre cable through from the CBT. and that allows them to deploy it. So you can see on the right-hand picture, the green one there has a blue rope, but actually on the grey one at the right has a black cable. So it looks like that's been deployed and actually has an actual GPON connection going in there. And if they have had something deployed, then you'll have an external termination box. You can see on the left-hand side, there's the grey one there that's Openreach, and that brown one is a Virgin Media one. And inside there are some components which I'll talk about in a bit. And also on the floor, there are, with Virgin Media, some cable termination boxes, sometimes called a TOBY, that allows them to do the last step from the street to the premise. So that kind of is a little bit of a tour of my local neighborhood of different connections, different kind of bits that you've got in the street. Because when taking pictures, it was sometimes difficult because there can be other obstructions in the way. But now let's take a look at the kind of network diagrams and look at FTTP and cable and see how it all fits together with some of the equipment that I've shown you, the whole network. So here is an FTTP network diagram. This is the kind of external side going from the head end, where there's the GPON equipment and the OLT, and that will connect to a kind of an aggregation node, and then there'll be fiber running over a large distance. It doesn't have to be, because of its fiber optic, it can run over a kind of a large distance, and there will be a kind of spine fiber that runs across to the fiber splitter nodes. At the fiber splitter nodes, you'll get up to around kind of 32 premises connected to one GPON section, and each splitter node can have up to 32 manifolds or connectorized block terminals, and each of those block terminals then has the individual connections going to each property. Normally there's kind of like maybe five or six connected, depending on the type of CBT, the different sizes for what's needed to cover it to the property. And the distance from the property to the CBT tends to be up to about 150 meters. And you'll then have up to around 32 connected into a group. It's a shared medium GPON, so it means that potentially the available speeds of overall kind of 2.44 gigabits per second of download bandwidth is shared between all the fibers that are connected to each uplink. It could be greater with XGPON or other technologies that give kind of 10 gig GPON, but currently deployed is just GPON. So it means that although the speeds that you're given might be, say, 500 meg or something like that, the actual guaranteed speeds, if everyone's downloading at the same time, could drop down to something like a guaranteed of 40 megabits per second with a kind of best effort for everything on top of that. But that's not something that's generally seen that much at the moment, because I don't think that there's the situation of having kind of 32, but it's something to potentially that is very different from FTTC, because although FTTC's got a lower overall speed, that connection is dedicated to that subscriber. So it does mean that the speed they get is based on the distance they are from the cabinet. But once they get that line speed, that's the line speed they get. Whereas with GPON, you might have a good line speed, but because it's shared, it means that the actual speed could be slightly lower in practice during peak times. So that kind of goes up to the premise. And then at the premise, we have a customer splice point. That's where the single fiber optic cable goes into the premise, and then one core is going to then go into the building. So if we look at that on the next slide, we can see goes through, and then it'll have a fiber connector going into the ONT, which is provided by Openreach, and that will have power, and then it'll have an Ethernet connection going out that then can connect to a router. So here I've got DrayTek router as an example. The connection could go directly into the ONT, or it could go into some RJ45 kind of Cat6 cabling to then place the router in a different position. That can be quite handy for wireless. For coverage, better to have it more centrally rather than right near the door, so it's possible to do that. And you don't lose any kind of connection speed by running Cat6 cabling around, because it doesn't degrade over distance. The demarcation point is at the ONT, so Openreach would be responsible for everything up to the kind of RJ45 presentation of the ONT, and the customer take care of everything on that side. So that makes it nice when it comes to troubleshooting and responsibility. So it means that you don't have to worry about the kind of same thing you would have on DSL with external cables, and reducing the sync speed. That sort of thing doesn't happen. But the actual cable itself that the fibre runs in is quite delicate compared to copper, so it's something that to be aware of, that you don't want to kind of break that, because that could cause an engineering call out. So let's now look at the ONT in closer detail. There's a few different variants of it. There were some that had voice ports on, but Openreach have moved away from that and now just provide ones that have a Ethernet port and then the optical fibre port. There also were some with battery backup, partly because of providing the phone port, but that's not how they kind of present it anymore. Because they don't offer the phone ports, then the battery backup isn't the responsibility of Openreach anymore. It's now the responsibility of the ISP that's providing the service. So there might be voice provided by the router itself. And so let's have a look at the different variants. There's a few that they're kind of around 5, I think, that you might typically see. The two here are the kind of more recent ones. If we look on the right hand side, you've got the Huawei and Nokia ONTs. It's called 1+0, which means it's got one RJ45 with no analog ports. And then on the left hand side, there's a housing, which can be seen in some situations. The idea is that the housing would be put on the wall, and then the ONT would go inside it, and then you can see their little see-through panel there allows you to see the LEDs. So the other thing to look at is also multi-dwelling. So I've covered looking at it from the point of view to property and external. It's slightly different if you've got multiple dwelling units. There, the fibre would go into the building, and what you'd have is a fibre splitter node kind of somewhere in the building, and then depending on how many floors there are, then fibre distribution points placed around it. So it's the same sort of principle as you'd have with the things under the street, but it's just slightly different, and the Openreach would work with any new build suppliers with speccing out how they put space for that, because they would want them to be in a place which kind of isn't kind of open access and isn't going to get kind of interrupted by anyone. And then but it's the same sort of principle there. You'll run the splitter cable with fibre going to an ONT, and then the customer has their connection in that way. The other thing to look at now is cable service. So just a brief history. So the cable operator that we have in the UK now is Virgin Media, but there was a few different operators over history, and it's worth looking at where it came from. Originally cable was to do with cable TV, and that's where the roots were in. So there was kind of in 1993, it started off as NTL, or there was a brand called CableTel that started off everything, and the initial focus was cable TV, but then shortly after that it started to add some sort of internet that's got faster and faster as standards have improved, and there's been a build of the cable network. They've moved from NTL, then a different company called TeleWest. They merged with in kind of 2005. NTL and TeleWest merged to become NTL TeleWest. Always thought the logo with the colon almost looked like it was perfect for that. And then shortly after that, in 2006, NTL bought Virgin Mobile, and then rebranded as Virgin Media, which is the brand that we're used to today. So we look at Virgin Media's network. The cable network is technically called a hybrid fibre coaxial network, and that involves fibre running from the kind of exchange equipment up to 40 kilometers to parent cabinets, at which point then it will run coax to distribution cabinets, and then and up to 150 meters from each distribution cabinet to the individual premises. From that point, you have the box on the outside of the wall, and then you have a coaxial cable going in, and then there's two connections coming out of that. You only need one of them, but it means that you can have something to another room, and then it goes to a RG6 coaxial cable that goes into a wall plate inside the property that then you connect the cable modem to. So here in this example, we've got coaxial most of the way, apart from fibre in the core. There is another version of this that Virgin Media have, which is almost full FTTP, and this is based around radio frequency over glass. This is slightly different to GPON, but it has the same sort of advantages that fibre has. It can run over longer distances, so you've got up to 60 kilometers and then up to 20 kilometers for the fibre cabinet to the distribution cabinet, so that it makes it deployment kind of gives more flexibility there. But then at the distribution cabinet, you will have up to 150 meters of coax. Sorry, no, that would be 150 meters of a fibre, but then it goes into a external terminator box that converts the fibre into coax. And the reason it does that is so that Virgin Media can deliver the traditional services by just having the same super hub, which is coax, so it's DOCSIS 3 or DOCSIS 3.1, and that means that they don't have to manage two types of router and modem. It's all DOCSIS kind of across the network, so even on the fibre it is DOCSIS technology, but then it's just only coax at the last bit from the actual property internally to the RG6 coax cables going in to the actual cable modem. This has some advantages for them to do with kind of the deployment, but it is kind of more expensive to roll out. But once they do roll out, it does mean that it could potentially require lower power, less amplifiers, because you don't have to have as many amplifiers in the system, and then they can layer on other technologies in the future. But in the meantime, I think it's going to still be FTTP plus that last few meters of coax, because of the delivery of the cable TV, and because then they've got these cable devices that they can just standardize on one technology at the customer premise. Now we look at the cable modem, take a closer look at it. There's kind of two I've got here, the Super Hub 3 and the Super Hub 4. The Super Hub 3 is quite a common one. It's DOCSIS 3 supporting, but if the Super Hub 4 supports DOCSIS 3.1. The DOCSIS 3.1 standard allows faster speeds, so that's what's enabling them to provide the 1 gig service, because it supports larger frequency ranges, and potentially that might be able to be expanded further to get speeds greater than 1 gig, and also the DOCSIS could change. There might be a DOCSIS 4 in the future, so they can still, over the same kind of core technology, upgrade some of that, and then continue pushing the speeds to be slightly faster. And we can see in the middle, I've got that picture with the broadband and TV. So there's from the wall, you've got the coax cable, and then there's a little splitter box that then you connect one cable into the broadband and one cable into the TV. And that's all a coax cable. So let's now look at how to connect DrayTek equipment. So there's quite a lot of flexibility in what you connect DrayTek wise. I've got some of the high performance ones listed here, the 2927, 2962 and the 3910. These are all Ethernet based WAN connections where you could plug into any of the kind of RJ45 WAN ports on there. But across the range, you can use the FTTP with any of our products that have a Ethernet WAN port. So something like the 2860, 2862, 2865, those all have an Ethernet WAN port, so can potentially connect to FTTP. The difference with them will be some of the firewall speeds that they can get, so the total throughput. I've got here a list of the difference in the total NAT performance. And as we've kind of upgraded our platforms, the speeds have increased. So the 2862 can do around up to kind of 400 megabits per second. So that's potentially usable on some FTP connections, depending on what sort of speed. So if you've got a kind of a 300 meg connection, that might be suitable. But if it's something that's more like 500 or closer to a gig, then it will be the bottleneck and the limiting factor. And the kind of other performances of the kind of IPsec and SSL is also faster on the later models. But let's take a look at how we would kind of configure with Virgin Media with the SuperHub and put it into modem mode, because by default it is a router in itself, but you can put it into modem mode to easily connect your own device. So kind of benefits of that is that, one, the SuperHub wouldn't have to do anything other than just the bridging. So that means that from a performance point of view, there wouldn't be anything else it would have to do, and then it offloads all of that onto the DrayTek, so it can do kind of all VPN, quality service, filtering, routing, and any failover as well. So it means you can have a one-box solution for failover if there happens to be an outage. But let's have a look at how we would put the device into modem mode. So what you do is log into it on 192.168.0.1 and log in with the password. That will be on the base of the actual unit. That's different to the Wi-Fi password. So you log in there. And once you get the welcome screen, you'll see a modem mode on the left-hand side. So you'd click on that, and then it will give you another menu. Where you can control whether or not it's in router or modem mode. So by default it's router mode, but you select modem mode and select apply changes, then wait kind of 5 minutes, and in the meantime you can then go onto the DrayTek and get that plugged in. You would connect the Ethernet WAN port, I've got an example of 2865 here, to the LAN 1 port on the Virgin Media SuperHub. The other ports, anything else that you've already got connected there, you would disconnect and connect to the DrayTek unit. And after you've configured the Virgin Media device into modem mode, it changes its IP. So its IP becomes 192.168.100.1. So if you did want to change it back out of modem mode, you'd put your PC back into the SuperHub and connect it on the new IP, 192.168.100.1, and then you can put it back into router mode if you wanted to. But then on the DrayTek router, after you've got the Ethernet cable connected to from the WAN 2 port or WAN 1 port, you would then connect the LAN ports to your computer on the DrayTek, and then we would log in to the DrayTek. So it's 192.168.1.1 by default. Log into username, password, admin, and admin. And then when you log in, you should see that on the WAN 2 or WAN 1, in this case WAN 2 on the 2865, it would then automatically get an IP address. It's by DHCP, so you shouldn't typically need to change anything on the setup, because that's the default. But what you do is you go into the WAN Internet Access and set the mode to be Ethernet and DHCP, and then it should get an IP address automatically. So it's quite kind of straightforward setup wise. There are in some cases on the business side a range of different kind of IP addresses. So if you've got I think it's VOOM 1, then that only supports the dynamic IP, so there isn't any static mode, and then modem mode isn't supported. With VOOM 2, it's kind of static or dynamic or one static address. And modem mode isn't supported, but it will work fine just with it set to a dynamic IP. And then VOOM 3 and others come with dynamic IP or with a range of IPs. So if it's in a range, then you can put it into modem mode, and then you can use it with the range of 5 IP addresses. But that wouldn't be available. It's a single IP. So that's the setup with cable with Virgin Media. So let's just look at the setup with FTTP. This is very similar to the sort of setup you do with FTTC, with the exception that you don't have to worry about plugging in the DSL port. So if we look at the DrayTek, I've got a 2927 here connected to the WAN 1 port, and we've got an ONT powered on, connected to the fibre, and then it's got the RJ45 cable going into a network port that's then running to the DrayTek. The first thing you do on the 2927 is log into the web interface and go to the hardware acceleration menu and enable that. This enables the kind of full throughput. It's something that isn't needed at the lower end, so like 300-400 meg, but if you enable this, then that allows it to provide the full speed up to kind of the mid 900s, 950, so that they can provide the full connection speed. And then you will go to the WAN and Internet Access menu, and then for WAN 1, set it to PPPoE, then go into the details page, and then select Enable. Put in the username and password. It will depend on the ISP. So if the ISP provides you with username and password, then put that in there. If it's with BT, then it would be something like BT Home Hub at btbroadband.com. For more residential connections. If it's a kind of a different connection, then you just put in the credentials on there, and that's all you need to do. It will then connect via PPPoE and get an IP address. That will get it the standard dynamic address. If there is a static address on the system, then that's possible to set up. You've got two different ways. So with WAN IP alias, you go into the WAN internet, and in the WAN IP alias button, click that, and then you can type in your static IP addresses, and that allows you to use the IP addresses in NAT mode, so you could use them for port redirections, but the devices behind would still have the private IP address and be protected by NAT. But alternatively, you can use it in routing mode with static addresses. So what you do there is enable LAN 2. So I've gone into the LAN VLAN, selected port 5 to be LAN 2. You could have more ports on LAN 2 if you wanted to, and then you go into the LAN general and enable that, select the details page, and then in LAN 2 enable it and select it for routing usage. Put in the IP address and select the subnet mask. It's probably going to be a /29, and then you can, if you want to, have the router give IP addresses via DHCP, or you can disable DHCP and set the IP addresses statically, with the gateway being the same IP you put on as the router IP address. So that's very similar to the setup you would use with FTTC. So it's kind of the same sort of principles. So that is the kind of general setup. And then we've got some things on troubleshooting. The nice thing about FTTP and cable is that there's less that can go wrong in principle, because you don't have kind of twisted pair copper and long distances, so it's kind of easier from that point of view. So it should, in theory, be a more stable connection. I've got a list of all the different kind of ONTs you might come across. There's ones provided by Huawei, Nokia, and ECI, and generally the things to look at are the power LED, the PON or LOS light, and the port. So if the power LED should be on, that shows that it's powered, and the PON should be green. If it's flashing, then it means that there's some communication going, but it might mean that it's provisioning. But if it's off, this means there's no fibre optic link. So in that case, you want to check to see if the fibre optic cable is connected. But if it does seem to be, then it would be a case of something that's kind of outside the property that would need to be looked at by the ISP. The port side, if the port isn't lit, but the PON and LOS are, then it would be a case of looking at the RJ45 cable, checking that's securely connected, and then looking at the router, because if the LOS and PON cable, or the optical LED is lit, then it would suggest that everything upstream is okay, and it would be a case of troubleshooting the router that's connected to. On cable, there's some things that you can get that are more kind of similar to some of the twisted pair copper stuff. One is if there's lots of different splitters in the premise. So you've got the one coming in, but historically there might have been kind of cable running to different TVs, or having it moved, and people might have connected different splitters. And what you can see when you log into the cable modem, you should be able to see a signal strength a value, and an example weak signal would be like minus 3 point something. A decent signal is kind of like in the 8 dBmV, and if this signal seems weak, then I would check to make sure there aren't any additional splitters that are inside the premise. Now, you wouldn't touch anything that's on the Virgin Media kind of external box. That's their responsibility. But anything inside past the point there, check to make sure there aren't any additional splitters that aren't needed. So that can be a common reason for poor signal or disconnections, because cable shouldn't really disconnect. It should be pretty stable. But another thing in troubleshooting is check to see if there's any problem. So one thing is that can happen is you can get damaged on the outside. So if there's anything wrong with that, then look at that. You can't really do anything about it, but you'd have to speak to the ISP to get them to come and look. But at least if you can identify where the likely cause, it helps with getting it fixed. And also with the box inside, check that is it looks sound, and also that the coax is plugged in securely into it. But you shouldn't interfere with either of these two locations, because they're the responsibility of Virgin Media. But that's kind of some general stuff on troubleshooting. There's some kind of useful links that we've got on the site. So you can search modem mode on the DrayTek site to get some support articles on how to put the Virgin Media device in modem mode. And there's some blogs on GPON and DOCSIS that go into kind of more technical detail, a bit more about some of the frequencies and technologies underpinning it, if you want to look in more detail. And if you've got any questions, then do contact us. So that covers the main presentation. Now I'm going to open it up for a Q&A, but first there's a few frequently asked questions I just wanted to look at. One is why not have a kind of an all-in-one box solution on GPON? It makes sense that if you could have a router that takes the fiber directly, then you just got one device you have to power, and that would be easier from the point of view of kind of installers, and potentially that seems like it would make sense. But it's something that hasn't happened, and I think it's quite unlikely to. The main reason I think to do with that is to do with GPON being a slightly different technology to VDSL. If you looked at VDSL, initially it was all provided by the ISP, and then they allowed other equipment to be connected. But with GPON, there's some slight differences. One is it's a shared medium, so the connection, that's something that's faulty there, could potentially affect other subscribers. And also from a security point of view, there's signals going in that it's kind of could potentially have a security concern if you've got other people connecting devices to the shared medium. And also from a compatibility point of view, to make sure the network's running reliably, and for troubleshooting, with a clear demarcation point from the ONT being responsibility of Openreach, it makes it easier for troubleshooting and fault finding. And also the cable is quite delicate, so you don't generally want that to be unplugged and replugged. That could cause some damage, and that would cause a kind of a call out that would be time consuming to fix that spliced cable. And also there's some things to do with provisioning with the ONT registration, so that if you had to get different devices registered, that would add an extra layer of complexity. So I think it is quite unlikely. And also we've seen kind of Openreach move towards a kind of a single box that doesn't include the voice, so they're handing that off to the ISPs being responsible for, and really focusing on kind of getting that maintenance and troubleshooting, so that they're able to control that device, update the firmware on it, and be able to monitor its availability. So that kind of, I think, bit of a summary on one box solution. The other thing is, which is better, cable or fiber? So it's a kind of generally a tricky question, because there's advantages of each. Generally, what you'll find is that GPON will provide lower latency. So because of the technology that's evolved with DOCSIS, it does tend to have a slightly higher latency, because of even with the FTTP deployment, they are then splitting it to from fiber to DOCSIS, so that adds a bit more latency as well, and that means that generally the latency is going to be slightly higher on a DOCSIS-based system compared to GPON. There are some potential deployments for the future that might reduce the latency further, so it's not something that's necessarily a permanent advantage for GPON. But there is additionally some, I think, issues with an Intel chip that was used by Virgin Media, the Puma 6, which was something that was known to kind of affect the Super Hub 3, which was an issue a few years ago, kind of in 2017, 2018. But that's something that was resolved, I think, towards the end of 2018, towards the end of the year there. So they've updated the Super Hub 3. So that shouldn't be a big latency issue, where there were quite a lot of latency spikes that some people were reporting. But still, even with that resolved in the firmware, also with the Super Hub 4 as well, that still is latency. And going from DOCSIS 3 to DOCSIS 3.1 isn't necessarily going to decrease latency, because what DOCSIS 3.1 does is it enables a larger spectrum and gives you faster speeds, but it doesn't necessarily change the underlying technologies. So it's still going to be a similar sort of latency from the Super Hub 4 to Super Hub 3. So that's one thing. But if you look at coax, it's slightly more durable than fiber. So there's kind of less things that can kind of go wrong with it from that point of view. The fiber is quite a delicate cable. But also when it comes to the speed, the DOCSIS 3.1 does enable kind of some decent speeds, and also potentially for the future as they go on, DOCSIS 3.1 might be able to enable faster speeds. So I think there's always going to be a continual race between the differents of speeds, but equally on the GPON side, there's a 10 gig GPON that might come out and be upgraded. So it's something that's, I think, going to be a continuing kind of race when it comes to the total speeds you can get on either. So now we'll try and do a Q&A. So if we look to see if there's any questions, I might be able to answer some of that over the audio. So give me a moment. I haven't been able to take a look at the questions, but I'll see if there's any that we can answer now. So one question is about kind of the shared bandwidth. Does Virgin Media have shared bandwidth in the same way as BT? And the answer is yes, they are. But I think that generally on the provision side, if it's a DOCSIS 3.1 area, the speeds in principle, I think, has a slightly better provision compared to the worst case scenario with GPON, although that's not necessarily seen as much at the moment because the install base for FTTP, I don't think, is that large in number of properties connected and the speeds people are seeing. So it might be that over time we'll see more people reporting some lower speeds, but there's still some guarantees with how they're with how Openreach are providing the speeds. But the answer to that, yeah, on the Virgin Media, it is a shared bandwidth in the same way, so it's shared by all the users. So it does mean that you can see variations. I think it's more seen on areas that haven't been updated to DOCSIS 3.1 than the DOCSIS 3, but in some cases they haven't. Not everyone's updated. So if it's on a DOCSIS 3.1, they can just update some people to have the 1 gig service, and then other people can be on the slower one. So that can help kind of mitigate that to some extent. There's a question about which is better comparing with the DrayTek products, the 2927 or the 2962. And the answer to that is the 2927 and 2962 should both work quite well up to kind of 950 megabits per second. They're kind of quite similar. The advantage of the 2962 is the slightly higher throughput with the 2.5 gigabit port, but that's not going to be any benefit for these specific technologies. So we should see the 2927. And another question I've got has come in about some existing devices. Someone noticed that I mentioned that you can use things like the 2862, but there's a question about speed. And one thing I'd recommend with people, if they're looking at a 2862 and using it on FTTP, you can enable hardware acceleration, So if you go into the router, enable hardware acceleration, that gives a bit of a boost. And also you can disable the WAN 1 port if you're not using it. So that can additionally help with the throughput to use with like 2860 or 2862. And that's going to give it the best possible max throughput that you can get on that. So it does depend, of course, what sort of line you're getting. If it's a kind of a 500 meg or 1 gig line, then it's a case of looking at the kind of 2865 or 2927s or higher. But you can get a little bit more by changing the config, because we didn't used to enable hardware acceleration on the products, because with 80 meg being the maximum on VDSL, it doesn't need hardware acceleration. But so that wasn't kind of enabled by default, but it is something you can enable on the routers to get a little bit more of a boost on some of the older models. And let's see if there's any other questions. I think that's everything I've got for now, but if there is any further questions that we haven't been able to reply to, we will be able to kind of answer you directly. We can respond to you via email, or alternatively, if you've got any additional questions, you can email info@DrayTek.UK, and we will be able to contact you and have a conversation with there. But also you can contact your support if you've got any support questions with any deployments you've operated in doing, or we're very interested to hear about your experiences and help you in any way that we can. So thank you very much for coming in. I hope you found that informative, and thank you for attending, and hope to see you at one of our next presentations later on. So thank you and goodbye.